So in this video we will talk about stress. What is stress? When external force applied on a body, then body resists to the external force. It's called the stress. So mathematically stress written as sigma equals to P upon A. Here P equals to stress, sigma equals to stress, P equals to external force which is applied externally on the body, and A equals to cross-sectional area. Unit of the stress equals to sigma equals to P upon A. Then unit of the P is the load equals to force. The unit of the force is Newton and the unit of the area is meter square. So unit of the stress will be Newton upon meter square. Types of the stress. Firstly, tensile stress. The stress induced in a body when subjected to two equal and opposite pull, as a result of which there is an increase in the length, is known as tensile stress. Tensile stress. You can see in this figure like this. This is the body and which is the pulling with the both side in the opposite direction. Okay, and it will be resist if it's pulling with here, and it will be resist from here. Okay, resisting force, then it called be resisting force. Likely we are pulling this body from this side, it will be resist from this side in the opposite direction. So tensile stress will be sigma equals to resisting force upon cross-sectional area equals to tensile load upon cross-sectional area. So sigma equals to P upon A. Tensile strain will be increase in length upon original length equals to dl upon L. Now secondly, compressive stress. The stress induced in a body when subjected to two equal and opposite pushes, as a we will apply the force on the body in the same direction. We will push the body. Because of pushing the body, it will be the length will be decrease like this. If we are pushing in this direction, the resistant force will be in this direction, and secondly like this, if we are pushing the body in this direction, the resistant force will be in this direction. What we have done in the tensile stress, the body was like this, and we were pulling in the opposite direction. Okay, now we are doing opposite. We are pulling in the same direction, and in the tensile stress we were pulling in the opposite direction. Here is compressive stress will be resistance force upon area equals to push upon area. In the tensile stress, what we have done, pull upon area equals to push upon area equals to P upon A. P equals to load or maybe force, and compressive strain will be in decrease in the length upon original length equals to dl upon L. What we have done in tensile stress, increase in length upon original length equals to dl upon L. Now shear stress. Last third one is shear stress. The stress induced in a body when subjected to two equal and opposite force which are acting tangentially across the resisting section, as a result of which the body tends to shear off across the section, is known as shear stress. Now we can see this in this figure like this. If I applied a force from the both side on this body, it will pull in the opposite direction, and the shear stress will be induced tangentially, and the shear force will be induced tangentially in this body. Okay, if I apply a force in the opposite direction at the end of this body, then the shear stress will be induced tangentially of this body. Shear stress will be represented by the toe. That's why toe equals to R upon A. R is the resisting force and A is cross-sectional area. Always always mind this. Shear stress is tangential to the area over which it's act. You can see this here. It's acting here tangentially of the body. Okay, clear this? Then shear strain phi, it will be represented by the phi equals to transversal displacement upon distance equals to dl upon h. Okay, that's all for today class. Okay, bye bye.